Hi there, so welcome back to the channel. Welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 55. We are going to continue from where we stopped on day 54, where we're actually looking at visualizing two quantitative variables using Seaborn for data visualization in Python. So welcome back to the channel. So if you want to follow along where we on day 54 actually, where we started this visualizing two quantitative variables, you can go to day 54 where we learned how to create two or four, two, three, four or more scatter plots using Seaborn in Python. So we just go ahead and continue from today, in which we'll be looking at customizing scatter plots. So how to customize our scatter plot and make it more visually appealing. So without further ado, let's get started. I'll just share my screen really quick there. So let's learn how to customize scatter plot in Python. So all datasets exercise files are that we've been using so far is already the link under the YouTube description. So you can have access to it by following the link in the YouTube description to download all the datasets and practice along with me. So our introduction to data visualization in Python. I'll just launch that and we continue from here.
So far, we've only scratched the surface of what we're able to do with scatterplots in Seaborn. As a reminder, scatterplots are a great tool for visualizing the relationship between two quantitative variables. We've seen a few ways to add more information to them as well, by creating subplots or plotting subgroups with different colored points. In addition to these, Seaborn allows you to add more information to scatterplots by varying the size, the style, and the transparency of the points.
Okay.
All of these options can be used in both the scatterplot and relplot functions, but we'll continue to use relplot for the rest of the course since it's more flexible and allows us to create subplots. For the rest of the lesson, we'll use the tips dataset to learn how to use each customization and cover best practices for deciding which customizations to use. The first customization we'll talk about is point size. Here, we're creating a scatterplot of total bill versus tip amount. We want each point on the scatterplot to be sized based on the number of people in the group, with larger groups having bigger points on the plot. To do this, we'll set the size parameter equal to the variable name size from our dataset. As this example demonstrates, varying point size is best used if the variable is either a quantitative variable or a categorical variable that represents different levels of something, like small, medium, and large. This plot is a bit hard to read because all of the points are of the same color. We can make it easier to read by using the size parameter in combination with the hue parameter. To do this, set hue equal to the variable name size. Notice that because size is a quantitative variable, Seaborn will automatically color the points different shades of the same color instead of different colors per category value like we saw in previous plots. Now, larger groups have both larger and darker points, which provides better contrast and makes the plot easier to read. The next customization we'll look at is the point style. Setting the style parameter to a variable name will use different point styles for each value of the variable. Here's a scatter plot we've seen before, where we use hue to create different colored points based on smoking status. Setting style equal to smoker allows us to better distinguish these groups by plotting smokers with a different point style in addition to a different color. The last customization we'll look at is point transparency. Setting the alpha parameter to a value between 0 and 1 will vary the transparency of the points in the plot, with 0 being completely transparent and 1 being completely non-transparent. Here, we've set alpha equal to 0.4. This customization can be useful when you have many overlapping points on the scatter plot, so you can see which areas of the plot have more or less observations. This is just the beginning of what you can do to customize your Seaborn scatter plots. Make sure to check out the Seaborn documentation for more options, like specifying specific sizes or point styles to use in your plots. For now, let's practice what we've learned.
So let's practice how to customize our scatter plots further in Python. So I'm just going to zoom in. So I have my file already launched here, my Jupyter notebook. So this is the MPG dataset, which is giving us information about different cars. So it's just a couple of rows of data, I think less than just above 300 rows of data. So this is the data set we're using for this introduction to data visualization with Seaborn or course. So it will be linked. I'll drop these files in the link in the YouTube description so you can practice along with me. Also, we've covered all these libraries in Python. Also, we'll work with all these libraries in Python. So let's see what we need to do in this lesson. So in this exercise, we will explore Seaborn's MPG dataset, which contains one row per car model and includes information such as year the car was made, the number of miles per gallon it achieves, the power of its engine, measured in horsepower, and its country of origin. What is the relationship between the power of a car's engine, horsepower, and its fuel efficiency, which is in miles per gallon? And how does this relationship vary by the number of cylinders a car has? Let's find out. So these are the key questions we need to answer in this exercise. So let's continue to use real plot instead of scatter plot since it offers more flexibility. So I'm going to use real-plot and MPG data frame. Use real-plot and the MPG data frame to create a scatter plot with horsepower on the x-axis and MPG on the y-axis. So you can see the horsepower. This is information about the horsepower and MPG information. So what is the relationship between these two variables? So I'm going to start with real plots. So we import matplotlib as PLT and import Seaborn as SNS, which we've done that in this first line of code here. So I'll just go ahead and create a scatter plot of horsepower versus MPG. Going to SNS dot real plots. So on the x-axis is going to be horsepower, comma on the y-axis we are going to have the MPG variable. The data set that we'll be pointing to is the MPG data frame. Hope I named it MPG here. Or I named it MPG here too. Then comma the kind of chart we want is a scatter plot. The scatter plots. Okay, let's see. Vary the size of the point by the number of cylinders in the car. So I'm going to vary the size of the plot. So the size is going to be based on this number of cylinders in the variable, which is this variable here, this cylinder column. Now let's do plt.show and see what we have here. For like you see. Now I'm just going to copy this line of code. So let's give it a shot here also. SNS is not defined. Okay, let's run the code again. Now let's see. Now see what we have here. You can see. So this is the MPG column. this column here, we are plotting it against the horsepower column, here. We are varying it based on the number of cylinders each car model has. So those that have 8 cylinders, the points will be bigger. So probably we still need to do some formatting, some customization on this variable so you can see more data points pretty well. Let's submit and move ahead. Now to make this plot easier to read, use hue to vary the color of the points by the number of cylinders in the car. So I'm going to add the hue, one more line of code here, and call it hue. So let's run the code. Like you see. So our hue is going to be added to our line of code to make it more readable. So if you run this line of code, let's see now. Like you see, this is more readable. You can see that those that have 8 cylinder type, those car model with 8 number of cylinders tend to have more horsepower and consume less fuel. As you can see, they consume lesser fuel here since they fall between here. Interesting. Good job. Cars with higher horsepower tend to get a lower number of miles per gallon. So as I said earlier, same thing. They also tend to have a higher number of cylinders, as you can see. So those cars that have higher number of cylinders consume less fuel per gallon. They have higher horsepower. Interesting. So let's continue exploring Seaborn's MPG dataset by looking at the relationship between how fast a car can accelerate, that is acceleration, and its fuel efficiency, MPG. Do these properties vary by country of origin? So note the acceleration variable is the time to accelerate from 0 to 60 miles per hour in seconds. Higher value indicate lower acceleration. So acceleration variable is the time it takes the car to accelerate from 0 to 60 miles per hour. Wow, in seconds. So from 0 to 60 miles. Ooh, that's quite a lot of numbers, eh? So we have the acceleration column here. Acceleration column. And what information do we need again? And its fuel efficiency. These properties varies by the country of origin. So I want to see if these two variables vary based on the country of origin of the car. Okay, let's see what we can come up with. Create a scatter plot of acceleration versus MPG. To make it easier and faster, I'm just going to copy this line of code and just change this to acceleration on the x-axis, MPG on the y-axis. That's correct. So the data set and vary the style and color of the plot by the country of origin. So vary the size. The size is going to be based on the country of origin, and color is going to be based on the country of origin. And let's see what we have here. While that is running, let's paste this here. Let's see what we have. Voila. So we have different from origin US, Japan, and Europe. So cars from US tend to have lesser miles per gallon, consume lesser miles per gallon of fuel, and has more acceleration, probably an average acceleration. While cars from Europe that consume more miles per gallon tend to have higher acceleration, which is bad. So the acceleration is supposed to be low. So let's interpret this data pretty well. Let's see. Now let's submit and see here. As the instruction says, okay, okay. As the instruction it says, note the acceleration variable is the time to accelerate from 0 to 60 miles per hour in seconds. Higher values indicate slower acceleration. Oh, interesting. Okay. I did a mistake. Vary the style and color of the plot point by country of origin. Vary the style and color. Oh, I'm supposed to be using style here, not scatter. Okay. So this has to be style. The hue. So I'm supposed to have hue here. This has to be in hue first and style. Styleness. Okay, now let's see. Well, I can see we have different style now. So let's make it better. So I'm going to copy this line of code and make use of it here. Voila. You see, so you can see different style. So the style or line of code here is going to use different shape to determine to represent each variable. You can see Japan is star, US is circle, and Europe is green. Is square rather. Let's submit and see. It looks good. Cars from US tends to accelerate more quickly and get lower miles per gallon compared to cars from Europe and Japan. As you can see here, so cars from the US, they tend to accelerate quickly, which is the lesser the acceleration, the better. So tends to accelerate more quickly and get lower miles per gallon compared to cars and consume lower miles per gallon compared to cars from US, Europe, and Japan. As as the number says, the higher values indicate lower acceleration. So if the higher values here coming here indicate that it accelerates slowly. Hmm. Let's continue. Oh, voila, we are moving to the next lesson, which is Introduction to Line Plots. So let's see how to do line plots in Python. So we just spent 17 minutes on the live stream. So let's learn about line plots.
Hello! In this video, we'll dive into a new type of relational plot, line plots. In Seaborn, we have two types of relational plots, scatter plots and line plots. While each point in a scatter plot is assumed to be an independent observation, line plots are the visualization of choice when we need to track the same thing over time. A common example is tracking the value of a company's stock over time, as shown here. In this video, we'll be using data on the levels of air pollution in a city. There are many air collection stations around the city, each measuring the nitrogen dioxide level every hour for a single day. Long-term exposure to high levels of nitrogen dioxide can cause chronic lung diseases. Let's begin with the simple case where we only have one data point per X value. Here we have one row per hour over the course of the day with the average nitrogen dioxide level across all the stations in a column called NO2 mean. This is a scatter plot with the average nitrogen dioxide level on the y-axis and the hour of the day on the x-axis. We're tracking the same thing over time, so a line plot would be a better choice. By specifying kind equals line, we can create a line plot and more easily see how the average nitrogen dioxide level fluctuates throughout the day. We can also track subgroups over time with line plots. Here we have the average nitrogen dioxide level for each region, north, south, east, and west, for each hour in the day. Setting the style and hue parameters equal to the variable name location creates different lines for each region that vary in both line style and color. Here we can see that the South region tends to have slightly higher average nitrogen dioxide levels compared to the other regions. Setting the markers parameter equal to true will display a marker for each data point. The marker will vary based on the subgroup you've set using the style parameter. If you don't want the line styles to vary by subgroup, set the dashes parameter equal to false. Line plots can also be used when you have more than one observation per X value. This dataset has a row for each station that is taking a measurement every hour. This is the scatter plot, displaying 1 point per observation. This is the line plot. If a line plot is given multiple observations per X value, it will aggregate them into a single summary measure. By default, it will display the mean. Notice that Seaborn will automatically calculate a confidence interval for the mean, displayed by the shaded region. Assuming the air collection stations were randomly placed throughout the city, this dataset is a random sample of the nitrogen dioxide levels across the whole city. This confidence interval tells us that based on our sample, we can be 95% confident that the average nitrogen dioxide level for the whole city is within this range. Confidence intervals indicate the uncertainty we have about what the true mean is for the whole city. To learn more about confidence intervals, you can check out DataCamp's statistics courses. Instead of visualizing a confidence interval, we may want to see how varied the measurements of nitrogen dioxide are across the different collection stations at a given point in time. To visualize this, set the CI parameter equal to the string SD to make the shaded area represent the standard deviation, which shows the spread of the distribution of observations at each X value. We can also turn off the confidence interval by setting the CI parameter equal to none. Alright, time to practice what we've learned.
Okay, so let's see what we can do with line plots. So interpreting line plots. Since we have just a couple of challenges here to do today, interpreting line plots, visualizing standard deviation with line plot, and plotting subgroups. So you can also do multiple line plots. Okay, so in this exercise, we'll continue to explore Seaborn's MPG dataset, which contains one row per car model and includes information such as the year the car was made, its fuel efficiency, or measures in miles per gallon or MPG, and its country of origin, Europe, US, Europe, or Japan. How has the average miles per gallon achieved by these cars change over time? Let's use line plots to find out. So we're going to create, we're going to be using same data sets, exactly. So this time around, we're going to be visualizing a line plot rather than a scatter plot. Okay. Let's see. So use replot and MPG data frame. Okay, I'm just going to copy all this one more time just to make it faster. Create a line plot. So instead of kind to be scatter, it's going to be kind, it's going to be line. Kind is going to be line. But this time around, our variable is going to change. On the x-axis, we're going to have the model year for the car. On the y-axis, we're going to have the MPG. That's correct. Line. So we don't need to specify the hue and the rest of this information. Let's see what we have here. Let's run the code and see. Well, I can see I see it increases over time. Let's see what we have here. Well, I can see our line plots showing MPG and model of the year. So the miles per gallon for each car increases based on the model of the car. Let's see information about model year. Maybe this are in the 70s, probably cars in the 70s. So these are information about cars in the 70s, in the 72s, 74, 76, 78, 82. So the miles per gallon is increasing over the year. Okay, let's see what we have here. So which of the following is not a correct interpretation of the line plot? So the average miles per gallon has generally increased over time. Is not a correct. That is correct. You can see the miles per gallon increased over time. The distribution of miles per gallon is smaller in the 1973 compared to 1977. 1973 compared to 1977. It says the distribution of miles per gallon. This is 1973. 1973 data points here. The distribution of miles per gallon is smaller between 1973 and 1977. That's correct. 95%, the 95% confidence interval for average miles per gallon is in 1970s, approximately 16 to 90.5 miles per gallon. 95% confidence interval average. What does that mean? Let's see. So the 95% confidence interval for average miles per gallon in 1970 is approximately 16. That is true. This plot assumes that our data is a random sample of all cars in the US and Japan. Hmm. So this is likely true. This is definitely true. The answer is between these two results here. That's incorrect. I said it. So it's definitely that first one. So this is a sample. So this plot assumes that our data is a random sample of all cars in US, Europe. That is a random sample. So the distribution of miles per gallon is smaller in 1973. 1973 to 1977. 1977 miles per gallon without the distribution smaller. So this is 1973, yeah, which is almost miles per gallon is showing in between 15, 16, probably 16, and for 1977, is higher than that. That should be correct, but let's see. Good job. The shaded region represents a confidence. Okay, the shaded region represents a confidence or interval for the mean, not the distribution of the observation. Okay. So this shaded region represents the interval for mean, not the distribution. So this is not correct. Okay. Now I know what that means. Oh, ignore this. We'll be learning off live stream for some time now. Okay, change the plot to the shaded area. Change the plot so the shaded area shows the standard deviation instead of the confidence interval for the mean. How do you change that? To show the standard deviation instead of the confidence level. So, in the video, remember that the shaded region is the confidence interval. So, which assumed data set is a random sample, that is correct. And 95% confidence that the mean is within this interval indicate uncertainty in our estimates. Okay. Now, if I want to include this, okay, say change the plot so that the shaded area shows the standard deviation instead of the confidence interval level. So, I'm going to add another line of code here called CI. Confidence interval level should show SD, which is standard deviation. Okay. Oh, voila. So let's do the same thing here. So this is going to show us the standard deviation. Mm-hmm. Oh, cool. This is outdated. So you can use error bars. Okay, let's see what they mean here. Probably DataCamp need to update their course, their curriculum. Let's see if it's still going to work. Ah, voila. So we still got same results. I'm just curious. Let me paste this one more time. So I'm still going to get same error, but we are still getting the same results though. Error bars, CI. Excellent. Unlike the plot in the last exercise, this plot shows all the distribution of miles per gallon for all cars in each year. Distribution of miles per gallon. Interesting. Now let's solve the last challenge. I think we have one more challenge to solve here. Plotting subgroups in line plots. So use replot an MPD data frame to create a line plot with model year on the x-axis and horsepower on the y-axis. Turn off the confidence intervals on the plot. Okay. Okay, let's create this. You could just copy this one more time. Oops. Alhamdulillah. So the model year on the x-axis and horsepower on the y-axis. Let's copy the horsepower line of code. Now we want the data should be MPG, our kind is line plot. Our CID, turn off the confidence interval level should be none. Just make it none. None. Just copy this line of code. I run this code here. Oh, you got an error there. Yes, we are going to get an error here. It says CI parameter is divided. Use the error bar. Okay, let's use the error bar instead here. In this instance, we still got same error. So what is our mistake here? So let's say here in this instance. Uh-oh. CI none. Oh, I'm not supposed to wrap it in quotes. Sorry. Voila. Let's do the same thing here. Well, I can see our model year and our horsepower. So the horsepower is decreasing by model year. Sorry. And the model year, they are the model year, the lower the horsepower, I guess. Wow. Damn, they're not doing better cars again. So create a different line for each country or region that vary in both line style and color. Oh, let's create a different line for each country or region that varies in both line and color. Let's see. You can see our CI is none. Then our So create a different line for each country of origin that will in both line, style, and color. Okay. Is it going to be by color? Country of origin. Let's see what we have here. So it now varies in both line. Let's see. Well, I can see for each country of origin, origin US, origin USA, origin Japan, origin Europe, a model year, model year, model year for each country of origin. But it says that varies in both line, style, and color. So I have to make sure it varies in both line, style, and color. Probably our size is going to be country of origin. Let's see. Let's run the code and see. Okay. So we're going to add one more line of code, probably two more line of code. Then one more style. Let's see. Ah, voila. I will just get rid of this size here. Hmm. Nice one. Hmm. Okay. Let's see. Ooh. So I have to use arrow bars each time. Oh, I always forget to use arrow bars, eh? Can you see I in Jupyter Notebook? It keeps bringing back this error. Okay. Interesting. So we just plotted three different uh line plots for same variable, but based on different country, US, Japan, and Europe. Let's see if we get it correctly here. Hmm. We nailed it. That's interesting. So add markers for each data point to the lines. So we need to add markers for each data points. So markers, we just add markers here. We just say markers. Just say markers to two. That's all. Voila, you can see. Why didn't I separate it? Okay. Add markers for each data point to the lines. Use the dash parameter to use solid lines for all. Okay, the dash parameter. So you want to make the markers to not be dashes. So we want to make it solid lines. I'm going to say dash dashes equals to false. Because since we have solid lines, let's give it a shot here. So our CI here, this is going to be error bars. Let me copy this error bar line of code here. Well, like you see, they have same chart, which is in three different line plots here in a single line plot, but with markers and solid line. Interesting. Nice work. Now that we have added some goods, we can see that this downward trend in horsepower was more pronounced among cars from the US. Interesting. So I think the horsepower from cars in the US went down. was more pronounced. That means horsepower cars from you were higher before and it went down over time. Interesting. So we've completed how to customize our scatter plots in Python. So I'm moving to chapter 3, which is going to be from the next slide, which is day 56. We're going to continue this on day 66, visualizing a categorical and a quantitative variable. Oh, interesting. So we'll be visualizing two quantitative variables since using Seaborn. Let's start to visualize categorical and quantitative variables on the next live stream. All right, so that'll be the end of the live stream for today. So if you found value in this learning journey of Python with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on day 56. So let's get back to work. Do have a wonderful rest of the day. I'll see you on the next video on the channel. Go watch the next video. Bye for now.